The sun. It's pretty complicated and dynamic. And here at the Smash News Network, least busted name in news, we bring you daily coverage of it. And thanks for tuning in. Congratulations on discovering our channel. Here it is in 171 angstroms, which is ultraviolet light wavelength, by the way, from the Solar Dynamics Observatory. Got some active regions rising, only one sunspot, some coronal holes. But the main story is a massive filament. We've got two active regions rising as well, and a coronal mass ejection captured from last night. We've also advanced our coronal mass ejection watch to a coronal mass ejection warning. We'll get to it in a minute. Here's ionized helium from the Solar Dynamics Observatory. And you get a great view of this filament up here. I'll put a box around it so you can see this darkened area. And I think the coronal mass ejection on the far side increases the likelihood of coronal mass ejection. It's actually why we advanced to warning. So let's take a look at the viewpoint from Lagrange point 1 to see last night's coronal mass ejection. This is the LASCO C3 coronagraph on the SOHO suite of instruments. And you can see this ejecta heading out here east of the Earth. To get a better idea of the way that is directed, let's take a look at Stereo A's coronagraph located here at Lagrangian point 5, where Earth would be to your right, and you can see that is on the far side of the Sun. We only forecast coronal mass ejections on the Earth side of the Sun. So if there's going to be a coronal mass ejection in this area, we forecast it. We don't forecast it in this area. Hope that helps what we're doing. Hope that helps you understand what we're doing. And once again, congratulations on finding our channel exists. Here are the solar magnetic fields, and you can see that sunspot 2858 has remained quite stable here over the past 24 hours, which is the time frame shown here in the imagery. Likelihood of solar flares not all that high. While it is still a beta class sunspot, it's looking pretty weak. And here's a great view of some coronal holes. These ones down here are South Pole oriented. This one up here is North Pole oriented. Just ahead of that filament, and you can actually see the coronal mass ejection from last night down here. I'll let it play through again. Right there, you can see that coronal mass ejection happen. The 10.7 centimeter radial flux is still at 75. There's the 1 year chart of that. The black line here is the radial flux. That's from Solon.info. The Space Weather Enthusiast dashboard not showing any geomagnetic unrest or storms in the forecast. There's your NOAA forecast for geomagnetism. And let's talk about seismicity. The South Sandwich Islands region has been mighty shaky lately. And this is the 90-day chart from Volcano Discovery. Let's scroll up the list and check out the swarm still going on down here by South Sandwich Islands. There was a 5.4 and a 5.1. At Fiji, we saw a deep quake at a 4.6. And this area right here is largely the deep quake capital of the world. More deep quakes there than any place else as far as I know. Leave us a comment if I'm mistaken. Also, there was a 5.3 at Tonga, so nothing over a 6 magnitude here. Some quakes in southern Alaska and southern California as well. Nothing too out of the ordinary going on there. If there was something we missed, let us know in the comments. Thanks for everybody who leaves a comment. And shout out to all of our viewers. Leave us a comment if you've never done so before, or if you're a new viewer, or if you're an old viewer who's never commented. Next, looking at volcanoes here, Karimsky on the Kamchatka Peninsula is exploding and producing an 8,000-foot plume of volcanic ash over the Russian peninsula. Also, Shiveluch, nearly twice the size ash plume there. It's exploding as well. 15,000-foot ash plume from Shiveluch. Suminosejima in the Ryukyu Islands, volcanic ash not identifiable in satellite imagery. Don't assume it's not erupting. Longila on New Britain, part of the Papua New Guinea archipelago is exploding, flight level 080 over New Britain. Mount Merapi, unknown volcanic ash height there. Don't fly your hang glider or John Denver style ultralight aircraft over it. White Island now showing up on the list again. White Island, New Zealand, the volcano that killed a few people. Was that last year? Because a tour guide didn't heed the warnings. Sulfur dioxide and carbon dioxide emissions continue. And very steamy conditions. No observations of fresh lava have been confirmed at the White Island volcano there, north of the North Island of New Zealand. Sangay in Ecuador exploding, flight level 220. That's a big uptick there at Sangay. 22,000-foot plume of volcanic ash. Revenador in that same country exploding, 16,000-foot ash plume from it. So Ecuador now a hot spot. Sabancaya exploding in Peru. Flight level 240. As it explodes, it's producing a 24,000-foot plume of volcanic ash. Please don't pole vault the caldera. It could be unhealthful. And frankly, we need the views on YouTube. Next, thanks to our patrons. Patreon.com/smAshomash is the location of our Patreon page. Thanks again to our patrons, the main source of funding for this content. Next, looking at the GOES 16 sun-facing suite of instruments. Here's the GOES X-ray flux and no major solar flares here over the past 3 days, or indeed the past several weeks. Just a B-class intensification here, which is actually still going on while we record the video. No spikes in the proton flux, and no surprises to regular viewers of our channel. Here's the GOES magnetometer over the past 3 days, and we're seeing a pretty big range here. So we saw a tight range yesterday, now a much larger range, and a little bit of indecision going on with the heliospheric current sheet as we see active regions rising here. Here's the top view ecliptic plane field plot showing you the polarity of the heliospheric current sheet. Keep in mind this data is about 45 minutes old, and the magnetic environment can suddenly change. We indeed did see some changes in some important stuff. We'll get to it momentarily. Here's the latest image. And you can see Earth right in the middle of a North Pole-oriented current sheet shown here in green. Next, the line of sight ecliptic plane field plot. And when you see that blue line waving around, it's an indication of a coming current sheet change. Anyway, Earth right in the middle of a North Pole one, no changes. In today's forecast, here's a line of sight coronal hole plot. You can see those coronal holes there. The main one is this North Pole-oriented one. If that stays as defined as it is, we can expect some geo-effective incoming solar protons in about 4 days. Next, detected sunspot groups. 2858 is the only sunspot that'll have a name today. It's been stable over the past 24, and likelihood of solar flares not all that high, as it's not very big and the fields are looking kind of weak, especially in the trailing umbrae. I think we'll show you that toward the end of the video as well, in high res. Global geomagnetism's pretty calm here at a KP of 1. And let's go to the real-time solar wind. All right, so current conditions are solar wind density 6.25 protons per cubic centimeter, solar wind speed 328 kilometers per second, pretty slow and nominally diffuse there. Again, 6.25 protons per cubic centimeter for the density, speed only 328 kilometers per second. Here's the magnetohydrodynamic pressure in the geospace over the past 4 hours. It's our geospace magnetosphere movie showing pressure as modeled by the space weather modeling framework. And you can see most of the pressure here showing up in the magnetotail side of the planet. To your screen right, the sun would be to your screen left, and you can see the illumination there on the Earth portion of the disk. It shows white on the sun side, black on the non-sun side. Next, looking at our other geospace magnetosphere movie, 4 hours of data on ground magnetic perturbations. Geospace delta B means changes to Earth's B field. And the B field is the field that goes through the magnet. We showed you the suns. Here are the Earth's at least changes in it. This is in nanotesla magnetic flux density, unlike the last, which shows nanopascals, which is magnetohydrodynamic pressure. We're letting this play through a second time here as it refreshed. And we see some significant perturbations here south of South America, south of the Drake Passage, and south of the Atlantic Ocean. And we decided to show an auroral forecast because we saw some ground magnetic perturbations here. And so we wanted to give people an idea of where auroras are most likely to be seen. If you're in one of these areas, go out, and if you've got clear skies, take some video of the skies, as your phone may pick up ultraviolet light and other portions of the electromagnetic spectrum not visible to the naked eye. Aurora almost always look more spectacular on film than they do to the eye alone. Next, a diagram of the solar system. Here's where stuff is today. We'll advance it 1 week. By the way, full moon coming on Sunday. And there's where things will be on August 27th. Next, a star chart. I like to use in-the-sky. If you want to put in your location, you can build one just like this using the all-sky chart is what we're looking at here. Saturn and Jupiter just about to set pre-sunrise. We came at you a little bit early today for the daily space weather. Are you like totally spaced out? We appreciate that. And thanks for tuning into the video. We're going to do a cosmology segment. We're going to make it separate. It's going to be a short video. Make sure you check our playlists at youtube.com/smashomash/playlists. All right, I'm not sure if we missed something here, so we don't see any charging hazards. The relativistic electrons have dipped. There's the 1-year chart from Solon.info. Here's the 3-day chart of the electron flux. Here's the relativistic electron forecast model, NOAA forecasting a continued dip in the electron flux here. Again, there are coronal hole winds on the way. Here's a diagram of Earth's Van Allen belts. Here's the total electron content forecast, and things are looking pretty normal here. This shows the electron density for the entire air column, and the likelihood of GPS errors goes up as this approaches the red. Most of them occur around the equator at noon. Here's a diagram of the Van Allen belts, because next we're showing the F ionosphere layer. So here is the F ionosphere layer in vibrational frequency. Millions of vibrations per second is a megahertz. And we see some minor anomalies here around the poles and around the South Atlantic anomaly. No surprise there. Here's the latest image. And it is from 8:15 Universal Time. Here's the anomaly map, which is departure from the 30-day mean or median. Those terms literally mean the same thing. And this is departure from the 30-day median in vibrational frequency also. So anomaly in megahertz. Some polar anomalies here of the low frequency variety. Nothing to write home about. Here's the latest image also from 8 o'clock, 8:15 Universal Time. Things looking pretty normal at that point. By the way, there's also a meteorology segment coming today. It'll be a separate video. Make sure you watch that if you haven't. All right, that was pretty sweet. There's a quick view of the U.S. region and water vapor. Here come bonus features, starting with Lermonth. It's the ground-based solar observatory in Lermonth, Australia, and check out all the filaments, especially this one up here. That is the source of our coronal mass ejection warning, which we just upgraded from a coronal mass ejection watch just last night. Here's some more imagery. Here's some more imagery from the GOES 16 SUVI. This is 284 angstroms, a wavelength we don't often cover on the channel. I like the electric blue to violet tones. I love me a good cobalt blue type color scheme. Next, the intensity gram. To show you continued degradation of sunspot 2858 and no other sunspots despite some active regions rising. Here's the colorized magnetogram, and we've pressed refresh. Here are the fields of sunspot 2858. And it looks like the main field is associated with the lead North Pole-oriented umbra. These South Pole umbrae are the weakest. Leading umbrae are the strongest, and again, it's looking like it's degrading. Here's some more imagery. This is 171 and 304 angstroms, a composite. Just spectacular imagery from the Solar Dynamics Observatory. Next, we're going to go around the horn, starting with this insane filament here that's getting closer and closer to Earth as the sun rotates. Like sands through the hourglass of time, so are protons through the solar wind. Here's the northwest limb, as we see this active region setting and a great view of sunspot 2858. We'll skip the southwest. Here's the southeast. And we'll be watching these areas in the southeast and northeast throughout the day here. We'll probably make another video when the coronal mass ejection happens. I'm expecting it in the next 24 hours. That's my best guess. And once again, thanks everybody for tuning in. And may that solar wind be at your back.